Okay, so in this lecture we will be going across, uh, be studying the ring opening reactions of thiophene. In the last video we saw the ring opening reactions of furan, so now we'll continue with thiophene. The thiophene ring can be opened up, but not in a similar way like we did for furan. This is opened up but in a very different way. Now this is opened using nickel, Raney nickel. This Raney nickel so not only reduces CS bonds but also the double bonds. Now if just thiophene, when it does when it when you when it reacts with Raney nickel, okay, what you end up getting is a simple butane. Okay, this is a very nice thing. So this, of course, in presence of hydrogen, and if you take any inert solvent like alcohol at 60 to 70 degrees Celsius, okay, so this is called, it does two things. First, it does desulfurization plus reduction of double bonds. Okay. So what is Raney nickel? So Raney nickel is a finely grained solid. Okay, so mostly composed of nickel, uh, derived from nickel and aluminium alloy. Okay, and this aluminium from this alloy is separated by leaching process. Now what happens is when this reacts with, when you leach it with sodium hydroxide, so aluminium hydroxide is separated out. Okay, and what you get is a solid. Now this solid nickel is powdered form, has very high surface area, so it's a nice absorb it's a nice adsorbent. So hydrogen is adsorbed on, when you treat it in presence of hydrogen gets adsorbed on nickel, and this hydrogen is what causes heterogeneous hydrogenation reaction. Okay, so therefore nickel is called heterogeneous hydrogenation catalyst. Okay, this Raney nickel is used most for its unusual property of reducing carbon sulfur bonds to carbon hydrogen bonds. For example, if you remember from your VIII Sem organic chemistry, a ketone in presence of BF3 and thiol, dithiols, you get your thioketals, and this thioketal, when you treat it in presence of vanillin nickel plus hydrogen, you end up getting a cyclohexane. So the CS bonds get reduces to this CS bonds gets reduces to CH bonds. That's the work of vanillin nickel. Okay. So just thiophene in presence of vanillin nickel plus water and alcohol solvent, inert solvent like alcohol, 60 to 70 degrees Celsius, we give you butane, simple butane. Okay. Now, when you carry out two continuous Friedel-Crafts acylations, for example, first acylation you carry out with R1 COCl in presence of catalyst as SnCl4 and R2 COCl, and again catalyst being tin chloride. So what happens is two consequent Friedel-Crafts acylation undergoes. Acylations. So this, since both 2 and 5 positions are vacant, you get acylated product. And now when you vanillin nickel, what happens? You end up getting six diketones. R1, how is it 1,6? Let us do the numbering. 1, 2, 3, 4, 5, 6. So 1,6 diketones. Okay, when your thiophene undergoes two consequent Friedel-Crafts acylations, and then when you treat it with vanillin nickel, you end up getting 1,6 diketones. Now, if you remember, furan, just as a reminder, when you did proton hydrolysis in acidic medium, you ended up getting, okay, if I put it some group here, R1 and R2, okay, you got 1,4 diketones. How 1,4? 1, 2, 3, 4, right? 1,4 diketones. So remember this variation small, don't get confused.